All right, so this is the at-home notes for the exponential functions and graphs in 3.1. We're going to have a test over 3.1 through 3.4 right before Thanksgiving break. Your homework at home is 7 to 23 odds on page 206. I'm going to tell you some things about an exponential function. They look like this, where you got y equals a to the x, and this a is going to be a number. So y equals 3 to the x is an exponential function. And just like always, you're allowed to stick numbers in here. So this is 3 to the negative 2 power, which is the same. A rule with negative exponents is you can move them to the denominator. If they're negative in the numerator, it makes them positive. So this is 1/9. So if you go over here to negative 2, you're at 1/9. You're just a little above the x-axis. And if you do 3 to the negative 1, that's 1/3, because you move the 3 to the first to the bottom. So if this is 1 right here, you're about 1/3 of the way here at negative 1. If you plug 0 in, anything to the 0 power is 1. So these graphs will normally go through 0, 1. If you plug 1 in, you get 3 to the first. 1, 2, 3, which is 3 when you plug 1 in. And you plug 2 in, and that's 9, and that's by far big enough to go. 3 to the third would be 7. But these graphs all look like this. And they just take off like crazy going up. That's an exponential function. Something that's growing exponentially right now is the coronavirus, if you want an example. So the domain on all of these exponential functions are negative infinity to infinity, and the range is going to be 0 to infinity with parentheses because it never hits 0. Y equals 0, or the x-axis will be your horizontal asymptote. Now this can change if you put, like, remember back with the transformations of functions, if I put negative 3, it'd move this whole graph down 3, and then we'd have to find the 0. So we're going to go over and do some homework problems. So these are problems off your homework, and I'm going to do a calculator problem and show you how to do this. So let me get this screen up right now. And let's see, we got 2/3 to the 5x power. So we got to do, you take your calculator, and I would hit alpha y equals 1. I'm going to back up and put a parenthesis, oops, wrong parenthesis there. And this is 2 over 3, and then arrow to the right, parenthesis. And then we want to go exponent, and it was 5. And I'm going to get the paper to see what it says, what the number was. Okay, so that was 5x, but it says x is 2/5. So right here we're going to say times, and then alpha y equals 1, and put 2/5 in there because that's what x equals, and we hit enter, and 0.4 repeating is going to be the solution to that problem. Now, I could have done that without a calculator, and I will show that to you real quick. Oh, I put the wrong number in there. It's 3/10 for number 10. I looked at the wrong problem, so I'm going to go hit second enter and go back over here to my exponent and come over here and put a 3 there and a 10 here and hit enter. So that is the answer I should have had. So this is going to be f of 3/10, because that's what I plugged into x, is approximately, and we're going to round this to 3 places. So it's going to be, oh, maybe I didn't show that to you because I went back over. So I had to go back and change this 2/5. If I hit just enter, it gave this thing back in there, and I went over and changed that to 3/10. And so 0.544 is rounding to 3 decimals. Okay, coming down here to this next problem. Again, this is, if you remember, the one I did originally is you can do a T-chart on all these, but these all look the same. Normally they go through 0, 1, but from transformations, that is up 1. So it will go up 1, and the horizontal asymptote will be moved up from the x-axis. It will be y equals 1, so there's a horizontal asymptote right through here. Your domain on all these is negative infinity to infinity, and since the horizontal asymptote's been moved up 1, your range is 1 to infinity. And I had originally put over here this graph because I was going to do a T-chart over here and plug numbers in like I did last time. You plug in 0, you get 1. -1's a half. 1 is 2. So this graph looks just very similar to the other one. It's not quite going up as fast, but it goes up in a hurry as well. So this is a mirror image of that. So again, you can put these numbers in here. You put 1 in there and you get 2 out. And this would be 1.5 here. And we're going to go up like this. And then this last problem is another one. It says use a graphing calculator to graph this thing. So we are going to take, we're going to have our calculator on. Let me get the screen up there. So we're going to hit y equals. And we're going to graph the function y equals 4 to the, I can't remember, I think it was x. I gotta look real quick. I put x plus 1. I think 22 actually says x minus 1. Nope, it's x plus 1. So it's x plus 1. So we're going to type 4, and then we're going to hit our caret key. And up there, we're going to hit x plus 1, and we're going to hit graph. And again, that looks like it's on the x-axis, but it's not. And it's going through the intercept of 0, 4, and I'll explain to you why that's not 0, 1 here in a minute. Matter of fact, I'm going to explain to you right now. It goes back to transformations because this plus 1 is with the x, so it moves all the functions to the left one. Oops. So if you plug in -1, that is 4 to the 0 power, which is at the 1. So let's move that 0, 1 over 1. And when you plug in 0, you get 4 to the first power, which is up there at 4. So this graph is going like this. And your horizontal asymptote is still the y equals 0. Your domain is still -infinity to infinity. And that is what you're doing on this homework today. So good luck at home. I'll take questions on the next day.